Okay, so in this video, what I'm going to do is show you how to perform a paired t-test using JMP. I have the paired t-test notes open from Blackboard, and there's an example on here, so let's give a look right past where all the notes are, and there's a skeleton version of the template for this. I have an example on weight loss, and I worked the example. I worked all the example and filled out the template and what have you. But what I'd like to do is show you how to actually perform it in JMP. So let's give a look here. It says, suppose you have data on a recent study on weight loss. You have the variables before and after weight on the diet for 8 subjects. You wish to check whether the difference in weight before and after the weight loss program is significantly different than 0. Basically, what we're trying to do right now is check to see if my weight loss program is working. So as you can see, there's 8 subjects there. And, for example, the first subject, here, that person started at 162 pounds, went on the program, and after, unfortunately, gained a little bit of weight. The next guy started at 170, did fantastic, went down to 136, and ... So the question right now that we're asking, is the weight loss significantly different than 0? Perform a paired t-test at the 5% level. All right, so remember, essentially what the paired t-test is, it's really a one-sample t-test on the difference column. Now, you have 2 options here, because JMP actually has a paired t-test option. So you could do one of 2 things. You could give JMP the before and after data, and tell JMP that it's a paired t-test. Now, JMP doesn't call it a paired t-test. JMP calls it a specialized test, and they call it matched pairs, because that's what it is. This data value right here, 162, is matched up with the 168. So in JMP, it's called matched pairs. So we could give JMP these 2 columns and tell JMP, go ahead and run the matched pairs t-test. Or we could subtract those pairs, and that's what I did here, and get a difference column, and then run a one-sample t-test on the difference column. Regardless of what way you go, you're going to get the same result. So let's do the matched pairs version first. So what I'm going to do is I'm going to pull up the template, which is already filled out. So in other words, everything's already here. So let's give a look on how we could run this in JMP. Now, what I've done already is I've taken the data and created a data table in JMP for the before and after data and a column for the differences. So I've entered that data into JMP. So remember, to do that, if you want to do that yourself, you would just go File, you would select New, and select Data Table. I'm not going to do that because I've already done it. But you select New Data Table, and then you could go ahead and type the data in yourself. There's only 16 pieces of data, so it's relatively small. All right, so let's do the matched pairs scenario in JMP first, and then I'll show you how to run the single sample t-test on the difference column. All right, so what I'm going to do is let JMP know, hey, my data is right here in the before and after, and go ahead and run the paired t-test for me. So to do that, let me open this bigger. You go to Analyze, and this Analyze menu, we've used it a lot, Analyze distribution several times, but this scenario for the paired t-test is in Specialized Modeling. And if you go down to the bottom of that, you'll see it says matched pairs. So I'm going to select that option. All right, so the matched pairs. So JMP calls the paired t-test matched pairs. All right, so all you really have to do is grab your 2 variables, which are before and after, and put them into the paired responses. So I'm going to just grab them and drag them in there. And say OK. All right, so let's give a look here. Couple things. It gives me the testing statistic, which is a t-score, about negative 3.71. Degrees of freedom, p-value, 0.0076. It gives me the lower and upper boundary for a confidence interval. It gives me the mean difference. And it gives me the standard error. As a matter of fact, you know what it doesn't give? Actually, it doesn't tell me the standard deviation of the differences. It gives you the average of the differences. In other words, this difference column that I created here, this third column, if you find the mean of those differences, it's about negative 19.375. the standard deviation of those differences, it didn't do that, unfortunately. All right, so let's give a look in the template and see, how this compares. So if I bring the template up, I'll try to slide this over so we could look at both things simultaneously. All right, so let's give a look. So in the template, as you can see, the alternative hypothesis, I'm doing a two-tailed scenario because, if we looked at the question, it says, are the two, is before and after significantly different from one another? A lot of people would argue, shouldn't we be doing a left-tailed test to show that there was, we lost weight here? I mean, we could set this thing up to be either of the three tests, depending on how you want to argue the alternative hypothesis there. But in any event, there's 8 pairs of data. The mean difference, 19.375. Notice in JUMP it says negative 19.375, and that just has to do with the direction that JUMP subtracted in versus the direction I subtracted in. When I look at the data, if I pull up the actual data table, this difference column, if I'm subtracting 162 minus 168, 170 minus 136, ... You can see that I get mostly positive results here. And this is representing weight loss. But if you subtract in the other direction, naturally these differences will be reversed. JUMP obviously put it in that order. Now you could have JUMP do it in either order, and that would be very easy to do just by, when I selected my pairs, select them in the other order, and it will subtract them in the other order. All right, so let's give a look here also. See where all the rest of this comes from. The p-value, as you can see, I already have in here, 0.0076. And that's over here in JUMP, right? 0.0076. Notice it's highlighted in red. I believe what JUMP does when the test is statistically significant, it highlights the p-value in red. Degrees of freedom, n-1. Critical t-score, notice that's not given here, which is kind of a letdown because remember the statistical calculators we've been using for all the hypothesis tests have actually been giving us the critical value. Now, don't forget, if you want that critical value, this 2.36, we can get it, don't forget. Like the alpha level is 95%. So don't forget, this is 95% because there's 5% alpha. This area right here is 0.025. This area right here, 0.025. And if you want to get this critical t-score of plus or minus 2.36, you could go to the t-table. But don't forget, we have, JUMP to do that for us. We could go to add-ins, teaching modules, and distribution calculator. We've used this thing a lot. Change to the t-distribution. Degrees of freedom were 7. And I want to input a probability and calculate values. And I have if we go back to the picture, I have a left area right here of 0.025. So in other words, if I want to see where that negative 2.36 comes from, this will be 0.025 area on the left. So I'm telling it, I'm giving you a left-tailed probability, and that probability is 0.025. And just click somewhere else, and it'll crunch it for you. And there you go, negative 2.3646. So, and naturally, if this value, the area here is 0.025, giving you a critical t-score of negative 2.36, then the equivalent t-score on the right-hand side is obviously going to be positive 2.36. So you could look this value up in the table or use JUMP for it, whatever you prefer. It's funny because the other menus that we've been using in JUMP, when we are here and we're using our add-ins and we're using the statistics calculators and we're using the hypothesis test menu in here, remember someone created these in JUMP. This isn't a built-in feature. We put this on as an add-in, and they, as an option, added to reveal the critical Z or T score, which is kind of convenient. The built-in menu for JUMP for matched pairs, this menu, doesn't do that, unfortunately, and they don't give us the critical t-score. It's kind of a letdown, but it's just what they decided to do. That's why people create add-ons. Most importantly, the testing statistic, 3.706, and there you see it right there, 3.7068. That 8 would actually round that thing up a little bit, but at the end of the day, you're just rounding this to about 2 1 to 2 decimal places anyway. Clearly, you can see the testing statistic is landing in the critical region, and the decision rule says to reject the null. Alternatively, the p-value for this test, which is 0.0076, is smaller than the alpha level. As a matter of fact, it's smaller than any alpha level we would select. It might be a wise choice right now to set this to be 0.01 to show a very significant test here. All right, so the test rejects, and we're feeling pretty good that this diet appears to be working. All right, so that's the first way to do this, and that's using JMP's what they call matched pairs calculator. Now, what about the other way to do this test? Well, the other way to do the test is to just basically do a one sample t-test on the difference column. So I calculated the differences here, and if I go to add-ins, statistical calculators, and choose hypothesis test for one mean. Yep, I have raw data. Now it's going to say, all right, what data do you have? And I have this difference data right here. Oops, sorry, hold on. My pen's freaking out on me. All right, so I have this difference data here. Say OK. And it's going to say, okay, well, what kind of test do you want to do? Well, I want to do a t-test. And I have a two-tailed scenario. Yes, the hypothesized mean. The hypothesized mean difference is 0. Significance level, 0.05. And yeah, reveal the decision for me. All right, and notice it gives you everything you need here. So if I go back to this template, things that I noticed that I could see. The sample mean, 19.375. That's the mean difference, 19.375. What I like about this menu is it gives you the sample standard deviation, 14.7836. Remember the other menu that we were looking at before, this menu, did not give me the sample standard deviation. Instead, it gave me the standard error. And if you're like, what's the standard error? 5.22678. What is that number? Well, that's the denominator, 14.784 divided by the square root of 8. In other words, s divided by radical n. But it's the standard deviation of the differences divided by radical n. You see, this menu here in JMP doesn't give you the standard deviation of the differences. It gives you the mean difference, and it gives you the standard error of the differences. This other menu, it gives you the standard deviation of the data, which is the standard deviation of differences, and it gives you the standard error. This menu, let's just be honest, this menu is better because besides the standard error, it gives you the t-score, which is the testing statistic, 3.706, right? And in addition to that, it even gives you the critical values and the p-value, and it tells you what we're doing to the test. Let's just be clear on this. This menu is a better menu, but again, it's not a built-in feature in JMP. So we're kind of having a workaround for the paired t-test here. So just remember though, how do we do the paired t-test? You've got two options. Do a matched pairs t-test in JMP using the before and after data. And this is two sets of data naturally. Or do a one sample t-test for the difference column. Regardless of which way you go, you're going to get the answer. Now, there is a downside, believe it or not, to using this menu right here. If you look around, you'll notice we don't have a confidence interval anywhere in this menu. But the built-in JMP feature, they did do a confidence interval right over here on the left. Upper and lower 95% confidence interval of the mean difference. So in other words, you're 95% confident the mean difference is somewhere between negative 31.7 and negative 7. And you should notice that 0 is not in that 95% confidence interval. Since 0 is not in there, what's going to happen? Well, since 0 is not in there, when you look at the null hypothesis, we're assuming that the mean difference is 0. Well, 0 doesn't live in the confidence interval. The confidence interval, again, if I look at it, the confidence interval runs from negative 32 about to negative 7. So the 95% confidence interval is from negative 31.7 to approximately negative 7. And notice that this number 0, it falls outside of the confidence interval.